Hello guys, welcome back to the new video. So today's Leetcode daily question is this redundant connection. So let's first read the question and try to understand what question asks us to do. Okay. So in this problem, okay. So first is given the definition of the tree. So what is the tree? Tree is an undirected graph. Okay, that is connected and has no cycle. Yeah, we already know that this is tree, which is not a cycle, no cycle, and it's connected means from one every node you can go to every other node. You are given a graph that started as a tree with n nodes labeled from 1 to n. So we have given a node from 1 to n in a graph with one additional edge added. And so for n nodes, if we want to make it as a tree, then we should have n minus 1 edge. Okay, but here we have one more edge, so total n edges, which is same as the number of node. The added edge has two different vertices chosen from 1 to n. It means that this edge, the extra edge, is not creating a self loop, because here mentioned that chosen from 1 to n. Okay, and was not an edge that already existed, and it's not the same edge. Means if we have, this is, let's say, 1 2, so the extra edge is not a 1 2, means not a parallel edge also. So they mentioned that no self loop and no parallel edges. Understood? Parallel edges. Okay, the graph is represented as an array of edges. This is given to us of length n, where edges of I is ai and bi indicates that there is an edge between node ai and bi in the graph. Okay, so we have to what we have to return an edge that can be removed, so that the resulting graph is a tree of n nodes. If there are multiple answers, return the answer that occurs last in the output. So we have to find that edge and then remove that edge. So we have to return the extra edge. And if there are multiple answers possible, that I'll show you in this first example on itself. So okay, so here what we have given an edges. Now we know that we have edge from 1 to n. So here, as we can see, 1 2 3, so we have 3 edge. So our n is basically 3. From here we can find our n. Now let's talk about the first edge, 1 2 2. The second edge, 1 2 3. Now third edge, 2 2 3. Now from this line, return that can be removed, so that the resulting graph is if there are multiple answer. Okay, so how can we hear multiple answer possible? It's like if we are removing this edge, yeah, then also we can get a tree. Mhm. Now what if we are removing this edge? Yeah, then also we are getting a tree. And here, if we are removing this edge, then also we are getting a tree. But we have to remove, if there are multiple answers. Yeah, as we can see here, there are three answers possible. Then return the answer that occurs in the last in the input. But we have to remove here 2 3, only 2 3. We can't remove 1 2 or 1 3, because this is the last in the input. That's why we have to remove this 2 3. Understood? Same thing here. First find the number of vertex. So from the edges, the length of this number of row is the number of vertex. So our n is here 5. The edge is dot size. From there you can easily find. Now we can remove this also, this also, this also. Yeah, one more thing, we can't remove this edge. Why? If we remove this edge, then our graph will become disconnected, and tree is not disconnected, as we saw in the definition that is given in the questions itself. So tree is not a disconnected, that's why we can't remove this edge. So what we have to do, yeah, we can remove this and this, but we have to remove only one edge, because we have given n edges, what we required n minus one edge. So what will remove, which edge we will remove? We will remove that edge which is in the last in the input. So 1 2 we can't remove, 2 3 also not, 3 4 not, but 1 4, 1 4 is the last in the input, so we have to remove this edge 1 4. Understood? So we have, if from this, if anyone understood or anyone find anything, then let me give you. So we have to think two thing in the mind. First, remove edge which is last in the input, last in input. And the second thing, it if, okay, if we removed any edge, then our graph our graph should be converted into tree, and we know that the tree is connected. So the second is for the connectedness, for the connected nature. Okay, so now how we will solve this problem? So we know that we have number of vertex and we are adding the edge, and if there is some edge which is repeated, then we have to remove. So are you able to map this with the Kruskal algorithm? How the Kruskal, in Kruskal, what we are doing, we are first sorting the all the edges based on the increasing order, sorry, in the decreasing order. Okay, sorry, in increasing order, as we have to find the minimum spanning tree. Okay, in the increasing order, and then when we are picking each edge, at the time of that we are checking that does it create a cycle. If it creates a cycle, then we are skipping that edge. So the same that part we have to check here. Yeah, the same thing we have to do here. So let me give you, uh, let me explain you with this example. So what we will do here, we will first take a node which is our n. Okay, now here we are dynamically making the graph by taking one edge at a time and checking. If it's not making cycle, then put it into the graph, and if it's make a cycle, then that will be our answer, because we don't want that edge to come. So here first 1 2, so make a edge from 1 to 2, checking the, okay. So for that, what we are using, we are using find and union, disjoint set, if you remember. If you don't know about it, then comment down below, I will explain you in separate video. It will be very easy. So here 1 and 2. So what we are checking, that the parent of 1, parent of 2, if they both are different, then we can do the union kind of thing. So here, yeah, that's true. Now we are adding 1 and 3. 1 and 3. So parent of 1 and parent of 3 are different. So we can join this. But when we are joining, try to join 2 and 3. So we can't, because the parent of 2 is 1, parent of 3 is also 1. So we can't join these two. Understood? So that's our answer. Now the same thing for here. We have 2, 1, 5, 3, and 4. Now let's start with the first edge, 1, 2. So if we join 1 2, the parent of 2 and 1 are different. So yeah, we can do the union. 2 3, parent of 2 and 3 are different. Yeah, we can do the union. 3 4, parent of 3, parent of 4 are different. We can do the union. 1 4, parent of 1 and parent of 4 are same, so we can't. Okay, let's hold it for a while. So we'll store this in our answer. Now 1 5, parent of 1, parent of 5 are different. Okay, understood? So this will be our answer. The same logic I implemented here. Is it visible to you? Okay. So what I did, first find the number of node with this. Understood? It will be very easy. First here finding number of node. Yeah. Then after that, here, yeah, as you know that for the find and union set, we require two things. One is parent and one is rank. Here we are doing the union by rank. So parent is initial. This is our parent declaration. This is our rank declaration. So initially, the parent of that is itself only. So this is what we are doing here. Now here check that we are taking n plus 1, because our node start from 1 2n. If it's 0, then here there is no need to this plus 1 extra. Understood? Now here what we are doing, we are checking the edges which is given as in form of array. We are taking u and v. What we will do, let's say here we have 1 2 2 3. So this is our u, this is our v for each element in the array. Now we are checking the parent of this and parent of this are not same. Yeah, then it will not form a cycle. Then we are doing the union thing. And if it's same, then is if you remember, then we are storing it over answer. Answer is our vector. That will store the answer. Okay. And at the end we are returning the answer. Now let me show you the code of this two also. This means this part. Okay. So this is for finding the union. uh okay, so this is for if parent of I equal to x. Yeah, this is will be, this code is for finding the parent. And okay, this code is for finding the union set. So how it will do is so first it will also check the again and the, okay, so let me write, this is code for the finding okay, yeah. Sorry guys, this code is for finding union by rank. If you don't understand that code, just write this and comment down below that you want a proper explanation about this, then I'll explain you everything. If you like this video, then do like and do share with your friends. Thank you guys.